welcome to Bar Z. My name's Stan, and today we've got a little project we're doing, and it's actually for Keith Finner. He's working on a little shop oven, low temp, not a super high temp oven, and he's using actually an old kitchen type oven, and he wants to fire the regular element that just for baking, but then he also wants to fire the broiling element at the same time. So he's doing a mod on this oven. So it was pretty interesting. It's a 240 volt unit, but we're going to adapt some controls so you can control the temperature very precisely. And I'm going to draw all the components on the board. What we're going to be using is the little Novus temperature controller. And we're going to use a pulse output. And we're going to use a couple of SSRs. We need two SSRs because we're 240 volt. I'm going to draw that on the board and show you why here in a minute. So we're going to go through all the components. We're going to go through the component wiring, and then we're going to get a little bit into the programming. So it's going to be kind of a start to finish thing where we actually program it to suit the needs of this oven. So they're very versatile little controllers. So let's get into it. Let's draw some stuff on the board, and we'll talk a little more about it. Okay, I've got a few components drawn here on the board. We're going to add some here as we go. We've got it's a 240 volt unit, so we've got line 1 and line 2 coming in with whatever control switch or breaker or whatever is on the lines. And then we've got a couple of fuses, and this is fuse protection for the SSRs, the load bearing on the SSRs, and the elements. So we've got two elements here. We've got two SSRs. And we've got the temperature controller, which is the little Novus. I'm going to try to let it focus on that. I'm going to pull this in and let the camera focus. And they even give you a little cheat sheet on the back. And these are kind of nice. They've got the little connector block just kind of snaps in there after it's wired. You don't have to undo the wiring. You can just kind of snap it in there like that. So it's a pretty quick change little unit. Easy to wire, and it's got a nice little legend there on the back. Anyways, we are talking about the Novus N1030T, which is a timer model. All right. But I've got that drawn on the board here. We've got the Novus drawn here and just a few components. Now I'm going to do, let's start with line 1. Then I'm going to do line 1. I'll try to color code this. We're going to do line 1 in blue. So line 1 comes in, hits a fuse, comes over, goes into our SSR, comes out of our SSR, and then it's going to go to both elements, as so. Switch to red for our next one, line 2. Right now we're just doing power wiring. Okay, so we hit the fuse, we come out of the fuse, go to the second SSR, line 1 in, T1 out, off to our heating elements. Okay, pretty simple. We've got a control switch. We're fuse protected. The fuses are protecting the SSRs and the two heating elements. All right, we still need to power up the controller. Now, another reason I choose this controller is, let's get back on that thing. It's over here on 8 and 9, way over here. And if you look, it says 100 to 240 volt. So it's a very versatile power supply. You can use it on almost any oven. So we do need to add another pair of fuses just for control. These are power fuses to control, to protect the elements in the SSRs from the heavy load. But we do need to get a couple little fuses in there, and you can just use the little glass fuses. These are cheap and easily obtained, as long as they're 250 volt rated. The little glass fuses. They do need to say 250 volt on them. So we're going to come out of there. We're going to draw those little tiny fuses, maybe up here, just little baby ones. So we're going to do one there and maybe one over here. Okay. So we got a couple little tiny glass fuses there. And then again, we're going to do line 1. We're going to come out of this distribution. We're not going to run a fuse through a fuse, but we're going to come to here, hit that one, come over, and then hit 8 and 9 as your power supply on the Novus. Okay, so that's the one. Let's get our red one in there. And we're going to go red here, down over here, and 9. All right. So now our temperature controller is powered up. Awesome. You know, we're actually doing really good. Next up, we're going to do, we got some control wiring to do, and we're going to be using the output. They call it output 1, and that needs to be programmed, and I'm going to show you how to program it later. But output 1 is the pulse, and that's on 4 and 5. Let it focus. Output 1 is the pulse, and you see you got a positive and a negative. So that's the pulse output, and those get wired straight to the SSR. And let's see, 4 and 5. Okay. You could run a Belden cable here, whatever. But out of 4 and 5, I'm just going to do these both in black. But you take 5, which is the positive. You can go down and hit positive. And 4, which is negative. And come down and hit negative and negative with a Belden cable, and just run those in parallel. You can run up to, I've run as many as 4 SSRs off of a single output, no problems. It's all low voltage. And this cable doesn't need to be anything special. You can use like a shielded alarm cable, a little Belden cable, almost anything, you know, small. 22 gauge is fine. There's one last thing to do. We're switching our elements off and on with the SSRs, so they're capable of pulsing now. And when I say pulsing, those elements will actually pulse, and the SSR indicator lights will actually just kind of flicker to maintain a specific temperature. All right. There's one more thing to do, and that's to add a thermocouple. Now, these are versatile enough that you can run multiple type thermocouples on them. You can run a J, which would be fine for this application. You could run a K, which is okay for this application. Today we're going to be using a type K. And those get wired on, let's go back to the controller. You see you've got 1, 2, and 3, which is your input, but we're only going to be using 2 and 3. If you use 1, 2, and 3, that's like an RTD input. But we're gonna be using 2 and 3, which is just a standard thermocouple. 2 being positive and 3 being negative. Make sure you get your polarity right. This is the cabling for type K. Type K is a nickel and a nickel iron wire. So, you know, if you use a J, it's got polarity as well. Make sure you check the polarity. And red is not positive with a K. So we come out of 2 and 3 here. And that just brings us to our sensor. And this obviously goes in the interior of the oven to sense oven temperature. All right, so that's it. That is the way that thing gets wired. It's obviously everything gets grounded. You know, I didn't show any grounds, but everything gets grounded. You do need to mount the SSRs so they stay cool. Put a heat sink on the back of them. Make sure there's plenty of airflow. And even if you have to cut a hole in the cabinet and stick the heat sink out of the back of it, I stick the heat sinks down with some double stick tape, which is like a thermal transfer tape. They use that for setting PC fans and stuff like that on PCs. So the thermal transfer tape works very well to keep your SSRs cool. When they're just either on or off, they don't really get hot, but when they start pulsing, they get hot. So you want to keep that silicon inside cool. And outside of that, the installation is very straightforward. All right. So let's move on to the programming. This is just going to try to make a quickie video here. We're going to power one of these little fellows up and go through the programming needed for this configuration, this exact configuration. And I will say that this is a K sensor, type K, but there's multiple types available within the programming menu. You can put almost any type of sensor on there you want. Alrighty, but we're going to be using K for this demonstration. Okay, we got our little Novus controller. This is straight out of the box. Hasn't had anything done to it. I've got a power supply run, which is just a 110 volt cord. Just got a lamp cord coming, so I've got a 120 volt to those two terminals, which are terminals 8 and 9. So this thing's going to power up. Oops, let's try it that way. And we're just going to plug that in, and now we should be powering up. And you see we're not showing any input, so we're all in red. We're showing an error. It's at 0. Nothing's programmed. This thing's dumb as a bag of hammers. So we're going to simulate the input with just a short piece of type K wire, which is basically just type K wire. Like I said before, one wire is pure nickel, the other wire is nickel iron, and so they're dissimilar. And we've just got the ends twisted together very tightly out here. So this will simulate a thermocouple condition. So we're going to, and remember I was telling you that it's pretty important to wire them correctly. And we can wire these in the fly. But here we've got positive and negative with positive on 2. So our yellow goes on 2. And our red goes on 3, as so. Focus. Come on. It's just not going to focus on that now. It was doing so well earlier. Just for the fun of it, let's wire it backwards. And I'll show you what happens when you wire it backwards. So we're going to put red as positive, as most people would think. And, we'll do red positive and yellow negative, which I know is wrong. But I'm going to show you what it does. Pardon the back of my hand. Okay. Now this is, it defaults to centigrade. I'm going to put this thermocouple over here. And I'm going to find a source of ignition and a source of heat. I'm just going to use a Bic lighter. We're going to heat up the tip of this probe and watch what this thing does. What it's going to do, it's actually going to work backwards. So see, with the temperature rise, it's actually driving the controller down. So it's all the way down in the negative. So now we're going to fix our mistake, our intentional mistake. And we're going to go ahead and flip that controller around and make it correct. And actually have our process temperature rise when it rises. We're just going to flip. Trying to keep my hands out of the way here. Okay, so now our thermocouple is wired correctly. And we will put it there, and we'll do the Bic lighter test again, just for fun. So it's showing, that's centigrade. So here we go. So see, she's on the rise. She's coming up. So that's the way you can tell if you invert your thermocouple wire or your thermocouple probe, either one. If you invert the wires, you'll see that problem. The controller will actually work backwards. Take care, because that can damage an oven if you don't pay attention and the temperature in your oven's going up and the controller's going down and it just keeps on outputting. You'll have what they call a runaway oven. So that's no fun. All right. So let's, yeah, she's starting to come back down now. All right. So let's just set that there. Let's get into the programming group. We're going to use the P button for all programming. It's either going to be a quick press to get you through a menu, or it's going to be a long press to get to the next menu group. And then to get through this menu group, this is the auto tune group. That gets you through there. Okay? And you press and hold, that'll get you to the next one. Press and hold again, that'll get you to the next one. Press and hold again. That'll get you to the next one. Press and hold one more time. Back to the main screen. So that's how you navigate through there. F is a function key. P is a parameter key. So, and then use your up and down arrows to set values. Pretty simple. All right, so let's let me get a cheat sheet out here so I can talk about every single one and not miss any that are required. And then we'll go from there. We'll start off with the first menu group, get through it with all the settings we need for this particular oven, and then I'll try to explain each parameter, what it does and how it affects you. So let me get a cheat sheet, and then we're going to start working through it. All right, well, I've got my cheat sheet, and it's not very big. There's not a whole lot of parameters to this. This is what comes with the controller. So keep this. Always hang on to your paperwork, obviously. We're going to go to the parameter set. We're going to push and hold till we get to the first parameter group, which is the tuning cycle. That's this parameter group right here. So we're going to get down through here. First one is these are just going to be a quick press, not a long press. So first one is a proportional band, which is set to 0. The P, the I, and the D is going to generate its own values after you get the oven fired. So right now there's not going to be any values. It's set to a 0 value, but when we auto tune it after it's installed, the PIDs get automatically set. Hysteresis is set to 1. Don't change it. Action needs to be set to reverse for heating. If you set it to the other one, direct is for cooling. So make sure you're set to reverse for the action of the controller. Output 1. Output 1 is what we're using as, if you recall, our output 1 is pulse. That's 4 and 5 right there. So output 1 is currently set to off. So we need to go to control. So output 1 is control. Output 2 we're not using. If you did want to use output 2 is a small relay. So that's 6 and 7. If you wanted to wire something into that relay, you could very easily do that and, set off an alarm or a light or whatever, but we're not using output 2. So that's going to stay off. And then we're back to main menu, and we've worked our way through the tuning cycle group and already done it. All right, we're going to go to the timer cycle, which is the next one. So we're going to press and hold. We see auto tune, and we wait for the next one. There's T1. T1 is your time interval. We're just going to leave that to 0 for now because we can set that from the main screen. This is your timer value. The T1 EN, this shows enables you to set T1 in the main menu. It's either yes or no. So we're going to leave T1 enabled in the main menu for the timer function. Next up is T direction. This is which way the timer counts, either up or down. I use down because that way when the timer is displayed, you see how many minutes are left in the cycle. It's not counting, to me that would be backwards, but I set T direction, or the timer direction, as down. Let's see. The timer start. This is what starts your timer. Now you can either have it so it starts when it hits the set point or starts with the F key. I always choose the F key, which is the function key. So those are your only two options. This one starts a timer when you've achieved your temperature. There, and this one starts a timer when you hit the function key. So I just use function key for mine. T2 timing setting interval. This is this lets you display it in minutes or seconds, and how it behaves. Okay. TICO is the control output behavior after the time interval 1 and 2. What we want to do is we want to turn the controller off. After we've timed out, we want the controller to shut down and the oven to shut down. So this is called they call this the control output behavior after the interval of T1 and T2. So after those timers have timed out, we want our controller to shut down. And then the last one is the T base, or how we want it displayed, whether we want it in seconds or minutes. I'm setting it for minutes, but you could set it for seconds just as easily. But our main display is going to be in minutes. All right. So that ends that control group. We just went through the timer cycle. here, and here. And now we're up to the input cycle. Again, we're going to press and hold. Press and hold again. Press and hold again. Okay, we're at type. This is the type of thermocouple we're using. You see TC is thermocouple. It's currently on J. We're going to go to K. But here's all the others. You got let's see, you got T. And then they've got another one called a PT100, which is the same one I'm calling an RTD. I think that's the 3-wire connection. So you got J, K, T, and PT100. So we're going to set it for K. Move on to the next. Decimal point. Where do you want the decimal point in your display? You can have it like that. You can have it like that. I choose that. Too much resolution on temperature and you just got numbers dancing around. So I move the decimal place over one. Next up is units. See, right now it's set for centigrade. We're going to go Fahrenheit. You can leave it on centigrade if you like. Offset. This is an interesting setting. Basically, an offset lies to the controller. If you've got an actual value in the oven of 100 degrees, but your controller is only showing 98 degrees, you would put a positive offset in there to make up for it and lie to the controller to fix something. You can go into the negative as well. You see we've got a negative sign here, so you can do positive and negative offsets. So that's a way to lie to the controller, and the calibrators use this if it's a very sensitive type of oven and it's maybe an environmental chamber or something like that, or a laboratory type oven, and they have to put an offset in there to maintain a specific temperature of the part. Maybe just because you're discharging 100-degree air into a chamber, maybe you have some loss in the chamber, some thermal loss, and you're only blowing out 95-degree air into the oven. Well, you lie to the controller and put a 5-degree offset in there. So the offset has a use. Next up, set point low. So this is the low limit of your set point that you're going to have control of at the main screen. So we're going to set low limit at maybe I don't know, 60 degrees, 70 sounds good. So we'll have a low limit of 70. Set point high limit. So this is subject to the mechanical limits of your oven. So you want to set that. Oh, I think Mr. Finner's oven's good for 600, so we'll go down to 600 degrees. And this is like your alarm clock at home. It just so easy to blow by your numbers. We could be here all day. See how close I can get. 13 degrees off. Okay, well, that's as good as I can get. We'll just use single button clicks and get us down to 600. Okay, that's the high limit from your main screen on the controller. Let's see. Function alarm is off. Set point alarm is off. That's blocking alarm is no. Hysteresis of alarm, that's the bias or the alarm deadband. And this should take us back to main screen. Okay, now you see we've got an actual temperature of 73 with a set point of 70. We're on the main screen. Let's see how we make it run. First of all, we press P and see if we've got anything on the timer, which we don't. Now T1 is where we set our timer now. So let's put it for a minute. Run is either going to be yes or F. Those are our two options. Right now, let's just hit run yes. Okay. So now the controller has got a run light, but we don't have a output light. So we have to raise the temperature above 74 degrees. Then we get an output light. And we can maybe simulate some of that. Right now it's in run hold mode, no timer. So we'll get our Bic lighter out here again. And we're just going to, when you see the output light, run tells you the controller is running, output tells you the controller is outputting, which in turn is outputting to the SSRs. We're going to put a little heat under this and start raising our temperature up to the 85-degree mark. When we pass 85, yep, we lose our output light. And then when it cools down, so I can put my fingers on that and force it cooler. Yep. Yeah, when it cools down below 85, you're going to get your output back. So that's what's throttling the temperature. Here's the 85, come on, 84, 83. There, we got an output again. All right. So that's, right now there's no the PID set in there, and I'll show you how to do that here when you get it actually installed on the oven. Okay, so now we showed you how to run hold. Let's run hold with a timer, or run with a timer. So we're going to go here. We got our timer set for 1 minute. We've got our run on yes. We're going to hit F. So our run is on the F key, on the function key. And now, see, we don't have any run command. We don't have any output, but you press and hold F for a 3 count. 1, 2, 3. And now we get a run, an output, and an A1. Now when you go to the timer, you'll see now we're blinking here. So the timer's sitting there running, and we've got a run command, we've got output, and we're showing the A1 contact or the timer in operation. So when we time down to 0, we're going to remove this run command. Okay, so right now we're displaying process value and our set point, both. And I'm sorry about the glare, this shop's bright. And you can always tell when your timer is running. You'll see that, you'll see this that little place right there blinking when your timer's up and running. When it's just a set value and not running, it's just on solid. And there it is. That's the end of our 1 minute, and we've removed the run command, and we've removed the output. All right, so that's the main screen. Main screen just gets scrolled through. T1 is where you set your timer. Run F, or your 3 choices are run F, run no, and run yes. Run yes is run hold. Run F is function key for timer. And then run no is just no run command and the oven's off. Okay. And back to main screen. Pretty simple. Let's talk about, we've got the controller in. We've got the thermocouple hooked up. We're firing an element. The unit's up on temperature. We want to set the PIDs. So we're going to press and hold. So we see auto tune. We're just going to hit that to, you got 2 options. You got fast and full. Do a full auto tune with the oven fully on heat, fully saturated, oven door closed. Don't mess with it. Leave it alone. And go back to main screen. And at that point, get your oven running, up and running. Run yes. There it is. Okay, now you're going to see a run light, an output light, and a tune light. Now the whole time it's tuning, it's going to do all kinds of crazy stuff. It's action and reaction. It's going to learn. Your controller is going to learn by the time it calls for heat, how fast does it get heat? When it calls for cool down, from the time it calls for cool down, how fast does it get cool down? So it's going to cycle above and below your set points to set those PIDs. And now after you've done this, when you're in auto tune here right now, we'll turn auto tune off because nothing's going to happen because we're not installed in an oven. Okay, your PBs and your PIDs set themselves. Right now, nothing is set, so so you don't get any PIDs in there right now. When you go in there, there's absolutely no PID set. If P has a 0 value, you don't get an I, you don't get a D. After auto tuning is complete, those will generate themselves. Make sure I didn't change anything I wasn't supposed to change. Okay, we're good. All right. Anyways, that's the Novus N1030T. Hope I answered all your questions. I showed you how to wire it. I showed you how to program it right out of the box and get it running for this specific application. The only variable you're going to have is your input type. You know, what type of temperature sensor you're using. All right. Sure appreciate you watching. Hope you found this informative.